Okay, technically today is 10.2, day 1. In honors pre-calc today, we're going to be solving trig equations that involve two equations and two variables. I'm just going to give you a quick second here to try to remember how to solve a system of equations where you have two variables and two equations. In a moment, this is going to be trig equations. All right. Oh, thank you. 3x plus 2y. Sorry. There we go. All right. I'm going to pause for a second while you give that a try. Okay, so to be able to solve this one, first, did you solve for y and say y equals 5 minus x? Subtract x on both sides. Is that how you did it? That'd be a way to do it anyway. Why did I do that? Because now I know what y equals in terms of x. So if y really equals 5 minus x, wherever there's a y, I can put 5 minus x. So I have 3x plus 2 times 5 minus x is equal to 14. Do you get from there, if I just solve for x, I've got the answer. I know what x is. All right, did you get x equals 4? Raise your hand if you got x equals 4. Okay, awesome. Then that's solving a system of equations where there's just normal variables. All right, now how about this little quiz? Problems 1 and 2 are just really simple. Do you remember these ratios and all, like 1, and then help me again. What's this one down here? What's this one? Good. And this other one over here, third across from the 30s where I always start, 1. And what's this one? Remember that these are both 2's, just one of them is a square root. So they'd be talking and like, you're a 2, 2? Okay, this one, square root of? All right, good. Okay, then that problem 2, you sine of 60, that ought to have been easy for you. Sine of 60 is opposite over hypotenuse. You should have said root 3 over 2. I want to make sure you're on that. How many of you were able to do that? Okay, good. Now, let's move this board up so everybody can see this better. And from here, we're looking at this set of nested triangles. There's a red one that's the bigger one, and then there's a green one that's the smaller one. You should be able, and I've kind of given you a lead here, like here's how you should probably do this. You're going to write one equation here, and the other equation here. And don't ask me if you can use your calculator to get tangent of 30, because I just proved to you a second ago, you know how to find tangent of 30. You've got the classic right triangles. You can look up tangent of 30. It's a fraction. Okay, so go ahead and write the equation for this. Tangent of 30 is TOA. It involves this and this. And tangent of 45, different equation, and you'll have a system of two equations again. All right, I'm going to pause for a minute while you solve that system and find out what x is equal to. Okay, my gut says that there's a couple groups that are really stuck, and I want to make sure that you're not starting with some wrong assumptions. So even though I'm not going to finish this, I want to make sure you started right. Tangent of 30, I'm going to make this a black triangle now. That tangent of 30, TOA, opposite over adjacent, h over 5 plus x. Raise your hand if you guys figured that out. Okay, awesome. Then the other one, the green one, I'm going to call attention to it by making it bright pink here. This guy. In that one, tangent of 45 is h over x. Now, do you agree that you can figure out what tangent of 30 is from knowing the classic 30, 60, 90 triangle? Did you replace tangent of 30 with 1 over root 3? Did you replace tangent of 45 with, well, figure it out from the classic 45, 45, 90 triangle. That's going to be a nice simple number. And then you'll quickly realize something about h and x. All right, in the end, though, I want what is x equal to. And you can't say h. You have to say, like, oh, it's 1.63 or whatever. Maybe it'll be 5 minus the square root of 2. All right, solve now for x. Pausing. Okay, I'm going to go a little further now and see if you could have done this. We figured out tangent of 30, TOA, 1 over root 3. So right here, we could put a 1 over root 3. Right here, tangent of 45. Ooh, that's pretty cool. That one works out to just 1. So do you get that 1 is equal to h over x, and then this other equation, 1 over root 3 is equal to h over 5 plus x. But what was the big one? What was the big moment? The big moment was that you should have realized that that means h is equal to x. And since h is equal to x, what are you talking about? It doesn't say that. Watch, times x by both sides. H equals x. It's true. And some of you might have even noticed this was a 45, 45, 90 triangle. So shouldn't these sides be the same as each other because it's in a 45, 45, 90? See what I mean? So it makes sense that h and x are the same. So if h is equal to x, then wherever h is, you can just put an x. 1 over root 3 is equal to x over 5 plus x. Now, I'm not saying that's super easy to solve, but just a quick side note. How could you solve it? Yes? So you want to use algebra? How lame. Can anybody think of a way to solve that? Besides multiplying both sides by blah, blah, blah. Oh. All right. This will be approximately the 17th time that I've asked a group of really smart kids how to solve an equation, and they forgot that you could graph both sides and see where they cross. See how it keeps coming up? In my first semester class, I have said that over and over and over and over, and you don't think of it as an option, and I get that. I'm just trying to pound it into your head, so when you're on the ACT and I'm like, I can't solve this equation, graph both sides, see where they cross. Now, I know there's another way to solve it, but, okay, first comment, side question. Go ahead.
So if you said like a test just for sine of 60 or sine of 30, you have to just write like 1 over square root of 3, or do you have to write h over 5 plus x?
Okay. So the question was, I'm gonna change your question a little bit. Your question really was, you would have to have both sides of the equation. You can't just not have this at all. If you just had h over 5 plus x, you don't have an equation. You just have a thing. You need both sides. But a better question might be, can I just leave it as tangent of 30? And the answer to that is no. You have to have that tangent of 30 replaced with this fraction right here. Because if it's a 30, 60, or a 45, you have to know how to simplify those down to these. So no, there's not another way, as far as I know, that you could have done this. You could not have just had h over 5 plus x. You'd have had to have both sides of the equation. Does that answer your question well enough, or not? Okay, then I will talk to you privately about your question later. I'll happily answer it, but I got to keep moving. So I've got these two equations, and I just know that we have so much to get to. I'm sorry, but I have to set your question aside for a bit. If I take this equation and this equation, they're just the same, except one's got an x in it where the h was. Now I can multiply both sides by x plus 5. I agree. We should know how to do this with algebra. I know you could graph both sides and see where they cross, but I need to get to the part where we solve this thing. That's gone, and now I have x plus 5 times 1 over square root of 3 is equal to x. That doesn't seem very simple. So what do? If I were you, I'd multiply this out. Okay, and I got to get the x's, so we have x's on both, or all on one side. So I'm going to multiply this out, and this first one, this times this, and then I'm going to do this times this. So I get x over square root of 3 plus 5 over square root of 3 is equal to x. All I did is multiply that out. Now I'm going to subtract x from both sides, and I'll have x over square root of 3 minus x is equal to negative 5 over square root of 3. Ooh, that was gruesome. But at least I got it down to just, I have x's all on one side. And now, It's a really hard problem. Could I have graphed both sides and stay with the cross? Yes. What's the other thing that I keep telling you over and over and over is usually the answer when you're in the middle of a really hard question? Yes. If you can factor it, you should. And see how there's an x in both of these? There is. There's an x in both of them, so it comes out, and I have 1 over square root of 3 minus 1 equals negative 5 over square root of 3. Oh, it's so gross. Yeah, it is. And now I'm going to get this out of here, so the x will be completely alone. So now I have x equals negative 5 over the square root of 3 times 1 over square root of 3 minus 1. And you might be like, I could have never done that. You'd have a calculator on the test. I just wanted to show you that it can be done, and there's actually a way to do it even faster and cleaner than this. If I multiply this back out again, it'll look nicer. If some of you solved it and got that, that's the same thing. It's more simplified. All right. So, what are the things I want you to take from this? Well, the stuff you're going to be doing on your test is not easy. That's one thing. Number 2, you're going to have to be able to find the triangles where there's like 2 triangles that are nested with each other. And you'll have to be able to write trig equations for them. All right, so now we're going to move on to a different problem that is going to be very, very similar and even more like what you would have on the test. Draw yourself this situation. You are walking across the desert and you look up and you see a plane. Do you see where the triangle is? Let me show you, in case you're not seeing it. That make sense to you? Ooh, there's a shock. It came out to a right triangle. Considering the context, trig and everything, yeah, that's going to be a big deal. All right, so now, if we already knew everything, there wouldn't be any math question involved. But we must know something. So we're going to say that we know that angle. Wait a minute. We're going to say that even though I know my drawing isn't perfect, that's supposed to be a right angle. And we're going to say that this is at a 30-degree angle. And there's a name for this. Do you get if the guy was just looking this way, that would be just like kind of normal and horizontal? But he's looking up. That's called an angle of elevation. They're going to use that term in your homework problems and on your test. You have to know what that means. Angle of elevation, generally you should think elevation means going up. So your eyes travel up to see that thing above you. Okay? Do you get that there's also a scenario in which you look down? That's not called an angle of elevation. Does anybody happen to know it? It's called an angle of depression. So when you look down, I know that also kind of like seems like depression. Like you never see anybody that's depressed like looking up and going, I'm so happy. Because it is an interesting body language thing there. If you're depressed, you tend to have your eyes looking down. All right, so anyway, angle of depression, that means an angle going down. Angle of elevation, that's going up. All right, so this problem has an angle of elevation of 30. Now, unless that jet is a Harrier jet, which they can actually hang in place in the sky. They can hold their position. Isn't that cool? They can vertically take off, and then they can hold their position, and then they can just go from there, fly across go to their next destination. All right, so for a moment, we're going to say the Harrier jet that was hanging there is going to start moving, and it's going to start flying over your head this way. So like 1 minute later, and don't worry, the 1 minute is not critical. 1 minute later, you see that the plane is now at a 45-degree angle. Except wait, no, you'll be able to use that little cheat trick that this and this are the same because it's a 45-degree angle, and that would make it too easy. Okay, so I won't do 45. I'll do 60. This is a 60-degree angle when the plane has traveled towards you. Now, all I have so far is angles. Have I trained you enough to know that just angles aren't enough? You need at least one side. In fact, if you had two sides, you could even figure out the angle. But I need at least one side. Okay, so I need something. Now, what I found in this problem is that it's too easy if I give you the altitude, the height. If I gave you this and I said the guy's at 1,000 feet, it's too easy. Now, why? Because you'd just instantly transfer it over here, and then you'd be able to get everything because you'd have a right triangle that has one angle and one side, and that'd be too easy. That's what you should have been able to do yesterday. So I'm not going to give you the altitude. I'm going to say that on your second reading of the plane, where you could tell it was at a 60-degree angle of elevation to you, that this distance was 1 mile. The plane was 1 mile away from you at that point. This is the unknown distance. I'm going to call it x. And the actual question is, once you figure out x, how far total was the plane away from you in the first place? At the first notice, obviously it's more than 1 mile. So the final answer I need you to figure out is, how far was the plane from you in the first place? Do you get we're going to write two equations, and it's going to have two variables? What are the two variables? I only see x up there. What was that other variable that I decided not to tell you? Altitude or height. Let's call it h for height. So do you get you've got two variables, and you'll need to write two equations? And now this time, you can use a calculator. Because it'll be a lot easier, that algebra won't be nearly so bad if you can just get decimals for things. So like if you need to figure out the tangent of 30, you can use a calculator and type in tangent 30, and you can get the answer. It'll be a nice clean decimal. One warning though, everybody look at your calculator and see if you are in radians or degree mode. You want to be in degree mode. All right, this is basically the same problem as last time, except now you know how it's supposed to kind of go, and you can use a calculator, so the algebra shouldn't be as bad. So write the two equations that have h and x in them, and then use your calculator to do the sine of, no, it'll be probably tangent. Let's say it's tangent of 60. Use the calculator. Just make sure you aren't in radians mode. All right, pausing for a minute while I give it a try. That's a good start. The black equation, tangent 30 equals h over 1 plus x. That one came from the pink triangle. Okay. And, second, my mouse is in the way here. And tangent of 60 equals h over 1. That came from the green triangle. Now, what's h over 1 the same as? H. So once again, we know the height. The height is the tangent of 60. I don't happen to have it memorized. Now, I could go make this thing. It's tangent of 60, so I got to make a 30, 60, 90. I usually draw that a different way. You all get to decide how you draw your own. But I'm going to make that the 30, 60, 90, 1, 2, square root of 3. What is the tangent of 60? Here's 60. Tangent, root 3 over 1, which really just means root 3. But I don't know what root 3 is, so I'd use my calculator. Or I could have just typed tangent 60, enter, and it would tell me the square root of 3. What did you guys get? Tangent of, you must have done tangent of 30 at some point, right?
Yeah.
What'd you get?
I got square root of 3 over x plus 1.
Okay, and if you wrote square root of 3, it's totally okay. Who used a decimal for the square root of 3? What did you get? 1.73 equals h over 1 plus x. Now, it's just going to be easier to use the decimal, and that's why I said use your calculator this time. And anyway, now, if I get Okay, I got to get h alone somehow. Well, wait a minute. I know what h is. H is the tangent of 60. Mr. B, did you get tangent of 60? Did you put in the calculator? Not yet? Okay. Okay, I just need to know what the tangent of 60 is right now. Yes? All right. Tangent of 60 is the same exact thing as the tangent of 30 was? Oh, dang. Sorry, somebody answered that one wrong. I was trusting. Tangent of 30 was what? 0.577. Thank you. And the tangent of 60 was what? Okay. So if h equals 1.732, then that's easy. I just put 1.732 right there. So 0.577 equals 1.732 over 1 plus x. And then I can multiply both sides by 1 plus x. And that cancels that. And now I'm going to divide both sides by 0.577. And you might have done it a different way. Let's just see if we got the same answer. So I'm going to take my calculator, pausing for a second. All right. So I got x equals 2. Now, just to clarify, that's not actually the question I asked. Let's go back to the original question. I asked you what was the total distance away in the first place. So if you just said x equals 2, then you just lost 5% because the question was, how far was it from you in the first place? So the actual answer is 3. Because it was 1 mile away plus this x distance, which we figured out was 2. So the answer at the end was 3. Okay. I know, it's challenging stuff. That's why you have a partner right now. And we've only gone through 2 problems in most of the hour. All right, we're going to do another one. Question? Are you just going to... Would 0.577 round to 1?
No, like, if you, like, divided it, like, before you, like, factored it, into the x plus 1.
Oh, okay. I get what you're saying. You're saying I could have multiplied this out. I could have, yes. But then it would have fixed itself later. The answer still would have been 2. The answer would be 2 either way. So I could have multiplied this out, but I didn't have to. You would not round it to a whole number. I rounded this. This was 3.00017 or something like that. I rounded that to 3. So I did a teeny bit of rounding, but okay. Fundamentally, what you have there is this. I'm going to give you a simpler one. It's like this. Do you get, I could multiply that 5 out? I need her to pay attention. Do you get, I could multiply this 5 in? But do you get, I don't have to? See what I mean? So you could have, but you didn't have to. And the answer, if I solve it, would be the same either way. If I had multiplied that 5 in, I'd get the same exact answer. All right, I got to get to my last example problem. So this is you standing up on a dock, and you see a whale. We're going to say that that's a whale that is swimming just under the surface of the water. I'm going to move this up because I can see a lot of people straining to see it. That's a whale, and how would you have described that 30-degree angle? That's an angle of depression. Very good. The angle of depression to the whale that's frolicking off the pier is 30 degrees. If I told you how far away the whale was, it'd be too easy. If I just said that this was 100 meters, then it'd be like, well, I could solve for h super easy, right? Do it. That would be too easy, but, you know, I want to make sure you can actually do it. Figure out how high up you are on the dock, or the, I think they usually call that a pier when you're up that high. All right, now there's two kinds of people. Are you the kind of person who used this pink triangle above it? Or are you the kind of person who used this green triangle that goes like that? How many of you are more of a pink person? How many of you are more of a green person? All right. I am the same way. I tend to do it with that green. But do you get it's a really common mistake then to put, oh, the angle of depression was 30, so I put a 30 here. That's not a 30. Do you get what I'm saying? If you're going to use the green triangle, you have to do that conversion in your head and say the total is 90 from here to here. So what is that green angle then? Do you get that 60 was never in the problem, but you have to like convert for that? All right. Okay, so back to, if I'm going to do this, now I'd probably, if I was using the green triangle, I would be thinking in terms of tangent, because I have opposite and adjacent, and you should have said tangent of 60 is equal to 100 over h. And then you would have solved. Raise your hand if you had that set up. Okay, good. Okay, so basically you end up with h is equal to 100 over tangent of 60, which you could use your calculator and get your final answer for that. Could I get it with a decimal or a fraction? Yup, because that's one of the classics. I could get that from a classic right triangle. All right, so that would have been too easy, though. I said that before. That wouldn't be a test question unless it was an R2. An R3 level question would be like this. All right, erase the 100. We don't know if it's 100. We know that the whale swims along towards us for 30 feet. And our new angle of depression, I'm going to make this a bright blue. Our new angle of depression, would you agree it's bigger than 30? That's not a right triangle. I'm going to try again. There we go. Do you get it's bigger than 30 up there? Let's call it 40. So this angle here is 40 degrees. Then what don't you know? You don't know the height, and you don't know this distance, which let's call this x, from here to here. This time I'll keep it simple. The question is, how big is x? Write two equations. Use a calculator if you want to. Once you get your equations written down, you'll be typing in things like tangent of 60 equals, or tangent of 40 equals. Now your homework for tonight is 3 problems just like these. You got to try 3 just like these. There's an answer key posted. But you've got to be willing to try these on your own. You're not going to have a partner for this. There is no partner test for this. I hope you caught on that these are all h. And it was the height to your eyeballs, technically. But that's where you were seeing from. So at this point, I'm going to use the pink triangle. And, oh, one more thing. You get this distance is 30. It's the same as this distance down here. And this distance is x. So I'm using the pink triangle right now. And I would have tangent of 30 is equal to h over x plus 30. In the other equation, now I'm going to use the bright blue triangle, and I'd have tangent of 40 is equal to h over x. From here, you just use your calculator to figure out what tangent of 40 is. Nobody knows that. And tangent of 30, you could look it up on the classic triangle, or just use calculator again. And you'll have to use substitution. Now, for those of you listening from other classes that are not in Mr. Server's class, I today decided not to try to teach bearing, because teaching this plus a whole other concept called bearings would be too much for one day. So I decided to not leave you all super confused. This is tough enough. The bearings, I'll squeeze that into tomorrow. So we'll talk about bearings tomorrow. Okay. The blue, light blue sweatshirt EB, type in tangent of 30 on your calculator. You're going to give me that in a second. All right. In the back row, KF, would you please figure out what tangent of 40 is? And I'm going to ask you for that in a second. All right, you ready with tangent of 30? All right. 0.58. So then I'm going to take this equation now, except I got to replace h with x because I want this to have an x right here. Can I just say h equals x? No. Let's find that out in the other equation down here. What was tangent of 40, KF? Can anybody verify that? Just making sure. Anybody get a negative answer for that? Okay, I'm thinking something went wrong with your calculator. Tangent of 40. Yes? Okay. If you get a really strange answer like that, it's usually because you're in radians instead of degrees. Okay, one more time, point what? 0.8391. Can anybody verify that one? Okay, good. Now I'm going to solve for h. .8391x. That means right here where h is, I can put 0.8391x. So now I'm going to rewrite this equation. 0.58 equals, and instead of h, I'm going to put 0.8391x over x plus 30. And I have to solve for x. I love that I can say, and from there, you just have to solve for x. You're in a hard enough class that that's supposed to be the easy part. So you'd multiply both sides by x plus 30. You'd have to get the x's all onto one side. But you're supposed to be able to do that. I'm going to keep it going just because this is probably the last problem we're going to do this hour. When you get to your homework, you're going to just do the first 3 questions of the homework. I'm going to pause for a second to show you those. So here is the first question from the homework, and it is way simpler than what we've been doing so far. So if you're like, I can't do those, I'm not ready for that yet, then you should be able to do this one. This one should be a happy place once you draw the picture. Okay, and there's this one, which I've labeled here, and you might want to put a sun up in the sky. Some people get confused where the sun is. So I've put a little sun there on the way left of it. You might want to do that too. The sun is to the left because it's casting the shadow on the ground. So the ground is down here. That blue thing, that is the lamppost, and it's annoyingly leaning over, because if it wasn't, the problem would be super easy. If it was straight up and down, it'd be a right triangle and super easy. So the blue thing is a tilted lamppost. But Do you get why this dotted pink one is in there? Do you get how that makes it a right triangle? That's pretty handy to have. And do you get around the outside? We also have a right triangle, the red one here. This is a right triangle also. So you got two right triangles. All right, so that's the second problem. And I'm not giving you like, ooh, this is a good challenge question. These are problems you'll have to actually know how to do. And last but not least, I want you to try this one, which is, remember when you're looking down, if I say there's an angle of elevation or an angle of depression, if I'm looking down, the angle of depression is like this angle. Okay, so when you're looking down from this building down to that building, this is the angle of depression. Okay. Do these three questions have an answer key? Yes, they do. You should try them. You should look at the answer key. And if you get the same answer as the answer key in a different way, totally okay. If you don't try them tonight and you come back tomorrow, it's not going to get any better. All right, do your part. Go try those problems, check the answer key, see if you're getting this. You'll be a lot smarter by the time we take the test, though. All right, I'm going to pause. Actually, I think that's it. That's it for the hour. Have a great day.